Welcome back. This is an Aleks training video on writing the electron configuration of a neutral atom with a filled d subshell. So we've done an electron configuration for an element that's pretty close to the top. Okay, I think we did carbon or something like that, where we had just one s2, two s2, two p2. I believe it was carbon. Okay, they're going to ask now for xenon. So xenon is pretty far down here, and you're going to have not just S's and P's, but you're also going to have D's. All right, so we have to remember something important and not very obvious from the periodic table. Scandium through zinc is a D subshell. Okay, so even the kid who used this book once wrote this. Here's your S's, main group S's, P's, D's, and then down here at the bottom, F's. You can't see. All right. The D's are they're in the row on the periodic table one farther down than their shell. Okay. Now the period, this is period 4, okay, starts scandium, but scandium is not in the 4th shell. Scandium is in the 3rd shell. So from scandium to zinc, this is in the 3rd shell. It's after the energy level is actually higher than 4s2, so that's why it's here. But this is in the 3rd shell. Remember, the 1st shell has one subshell, S. The 2nd shell has 2, S and P. The 3rd subshell has 3, S, P, and D. Here is 3D1 through 3D10. So when you get back here, you're back in the 4. This is 4p. So this is 4s1, 4s2, 3d1 through 3d10, 4p1 through 4p6. When you get back here, now you're in 5, 5s1, 5s2. This is now 4d. All right, 4d through 4d10, back to 5p, 1 through 6. So we're now at 6, 6s1, 6s2. Okay, then you get into the F subshell. The F subshell are 2 away. Remember, the 4th shell has 4 subshells, S, P, D, and F, but you don't find lanthanum until you get to 57. So 57 is after barium, so that's 6s1, 6s2, 4f1. Okay, so the D's are 1 off, and the F's are 2 off. Now the F here, these two guys fit in this little crack, so it's actually 3-dimensional. It's coming out and coming back in, and then this last one here is one of the D's, and it comes all the way down to here. So you have the F's first and then the D's. Okay, so they're asking for xenon. So let's look at xenon first, and then we'll write it down. You're going to have to do 1s, 1s, full. You're going to have to do, let me pinch this down, 2s, 2p, 3s, 3p, 4s, 3d, 4p. Now we're in 5, 5s. Now this is 1 off, so this would be 4d, and then back to 5p. And that'll get you to xenon. Okay, so we're wanting 5p6 is xenon. So we want everything up to 5p6. All right, so what's it going to look like? So you're going to say, okay, xenon is 1s and it's filled with 2. Okay, remember there's 1 orbital, 2 girls. Okay, so that's full with 2. Now we're at 2s2, 1 orbital filled with 2 girls. Now we're at 2p6, 3 orbitals. Okay, so that's 2 girls in each room, 3 rooms, 6 girls, 2p6. Okay, now the 2nd row is finished. Now we're back to sodium. We're at 3s2. Okay, now we jump to 3p6. This takes us as far as argon. Now we're at 4s2, That's potassium and calcium. Please be looking at a periodic table or else this is gibberish to you. Okay, 4s2. Now we have to go back into the Ds. So once we get past calcium, number 21 scandium, this is 3D, and it goes, there's 5 rooms, 2 girls each, so 5 orbitals, 10 girls. We're now into the Ps, but we're into the 4p, 4p6. Okay, 4p6 is krypton. Now we're in the 5th shell, 5s2. Okay, now after S's are D's, but I'm one off, so I've already done 3D, so now I do need to do 4D. It's full up to 4D10, and now we're back into 5, 5p6. Okay, that's xenon. Now this is really long, and you're going to see that the lower down on the periodic table, the longer this address gets. You'll eventually have a shortcut. Let me give you a shortcut. Krypton is the noble gas directly above xenon, on the previous row. It's number 36. So I could also say xenon is whatever the electron configuration of krypton, and then continuing into 5s2. Do you see I'm here? So 4p6 is krypton. So instead of writing all this, you would say krypton, 5s2, 4d10, 5p6. So this is the shortcut version. This is the long cut version. Either way, it's kind of like